Hi, my name's Ihe Onwuka, and this talk is about SchemaCom and XML Schema Comparator. So a bit about me. I was enticed into XML around 2003 by a consulting director who I used to work for, who convinced me by saying, it's just like COBOL. So currently I'm working as a systems engineer with LS Technologies on the architecture of complex data models for the US federal government. So let's get into this problem. So schemas change, but the ways in which they change are often not fully communicated or documented. So we have this problem of needing to port existing data so that it's conformant with the new vocabulary. And in order to do that, you need to know how to map the components of the from the old vocabulary to the new one. So this is the challenge that we're faced with. So you've got, in essence, a schema comparison problem. Now, schema comparison has been addressed by a number of people. The link at the bottom there is to some documentation produced by Delta XML, in which they explain what it entails. The top quote there was by Dr. Michael Kay, who describes it as quite a challenge, and the one following that was from Abel Braxma, who suggested that it was not something you want to do by hand because it's quite complex. So by this time you may be wondering, why is this fool wading into this area where angels fear to tread? This is some of the stuff that's already in this space. This is a tool called SchemaDiff. In the first three cases that you see, you've got they're all complex types which are changing because an element's been added. Here it's an element called new element test. Here it's an element called availability and also manufacturer. There's also an annotation that's been added. In the last case, an element called ID was changed from type string to identifier type. So that's one tool. Here is another, Stylus Studio. I've actually mentioned a second one called DiffDog because in the respect I'm going to talk about, they are quite similar. Here, what you do is you specify the mappings between the two schemas. So you map a component from in the from vocabulary to the next one, indicated by a line which joins the two. So there are some issues with both these tools in the sense that they don't help us know what the mappings are. So first of all, there's several ways in which schemas can change which don't actually impact the mapping. So for example, annotation, well, that's not going to affect how the mapping, neither does ordering. I mean, what you have to map doesn't change, and maybe the order in which you need to include it in the new schema changes. But that information is already given to you in the target schema anyway, because you can just look at the sequence and it will tell you in which order things needed, the order in which things needed to be added. And also the type of primitive. So you might go from one kind of string to a more restrictive kind of string. Well, essentially that's not really going to change the mapping. It's just maybe it may affect the validation. So there's quite a bit of information there that's not helping us in understanding what we actually need to map. Okay, and then the second class of tools I mentioned, which is the Stylus Studio and DiffDog, are allowing us to map things, but once again, they're not telling us what we need to map. You need to know what you have to map in order to use those tools. It's not going to tell you that, okay, in the old version, you have to map X to Y. It just says, it just allows you to map X to Y. So this is not helping us understand what has changed and what we need to map between the versions. So let's have a look and see how the SchemaCom user interface helps us solve this problem. Here you have the user interface. It features 4 tabs. Drop complex types as things we're dropping from the source schema. New complex types, things that have been added to the target. Matched is where we've got things that have changed but are neither dropped nor added. And identical is complex types that are unchanged. Okay. At the top here, this is a selection drop down where you pick the pair of schemas that you're actually going to compare. And there's a search button here. So our challenge here is figuring out what's happened to feature type. We can see it's been dropped, but does that mean it's disappeared entirely, or has it been given a different name in the new version, which we aren't told. Now, where would we start looking for this information? If you didn't have an SME at hand, you may well not know. So if we click on the feature type button, we get an expansion of the content model, and you can see here the @ sign that you can see here signifies an attribute. So you've got 4 attributes: center, source, system, and timestamp. In brackets is the type of each attribute, and then below in italics are what I call annotations, and the annotation tells us what the complex type for that, what complex type that attribute name features in the target schema. So this is, so for the first one, this is saying that my attribute center is of type provenance center type, and in the target schema there is an attribute called center in provenance type. Okay, so the idea is that if the actual complex type itself didn't migrate over to the target schema, maybe its constituents did, and if they migrated en bloc, or the more of the content model that reappears in some other type in the target schema, the more likely it is that may be the mapping that we should make. This is a guess, it's not precise, but in the absence of, as I said, a subject matter expert to tell you, or documentation telling you, then this is the best that we can do. So if you look at the source attribute here, you can see that an attribute called source appears in how many? 1, 2, 3, 4, 5, about what, 6 different complex types in the target schema, right? And so this is the guess we're going to make. If we see, we can see that in each case, provenance type appears as one of the annotated complex types in the target. So based on that information, what I've done is I said, okay, provenance type was a good guess. If I just go back here and see provenance type appears in all the annotations. So that's my guess. And so what I'm asking it to do is I'm putting in a search on provenance type. So one question you may ask is, why is feature type appearing in the search for provenance or PROV? And that's because the search is designed to search not just for the complex type, but also for the constituents in the annotations and the content model. Okay, so by dint of good fortune, we have feature type appearing here, and we've got provenance type appearing in the new complex types. So let's go forward a little bit and expand now. So we click the feature type button and the provenance type button. Now look at the provenance type in the target schema. Right? It's got center, source, system, and timestamp. So this is a pretty good candidate for us for our mapping. Now, Notice though that in the target schema, timestamp has no @ sign, which indicates it's an element. So in the course of migrating to the target schema here, it looks like timestamp changes from attribute to element. Now, another way in which we could look at this is that we could look at the annotations on the in the target schema, because they interpret in the same way in the direction. So it's showing that the content model in the target schema all seems to be present in the feature type, complex type in the source schema. So that's a fairly good indication that we should be mapping feature type to provenance type in the target schema. Something else that we can use this for, look at the match complex types. So here we've got surface event type for version 4.0 and version 4.1. They look pretty much the same. Spelling's all the same, but notice that what's actually happened is that everything in 4.0 was an element, and it's now the content model is all attributes in 4.1. So that's something that we might not have spotted with the naked eye. Some more things. Look at the top here, under communications capability type in version 4.0. Why is it coming up as something that has changed? Well, look closely and you see that the data link, the L in data link in version 4.0 was uppercase, and in version 4.1 it went to lowercase. Now, good luck trying to spot that yourself. So if you hadn't made this mapping conversion, then the new instance would fail validation because it's not spelled in the correct case. Further below, something similar. What seems to have happened here is a correction of the spelling of facsimile, but it's something that you may well not notice, especially if you don't know how to spell facsimile. Another type of thing here is what I'm calling superset content models. Now, basically, in the match complex types, what appears if you expand the content model by clicking the button, what will appear are things that are not present or have changed in the from the previous version. So where you have something appearing, with only one version, so that indicates that that version supersets the other version. Now, talking here about validation aids, and what I draw your attention to here, by the way, this is a different schema, this is SAML, but what I draw your attention to is at the bottom here, we have response type in version 2.0 twice. So this is either a duplication or it's not, because the namespaces are different. Now, the lesser of the two evils was to make the application not namespace aware, because if you now differentiated them, well, typically what would have been done is that we would have used a prefix and then said, oh, they're different types if the prefix is different. But of course, as you know, prefixes being different does not necessarily indicate that they are not in the same namespace. So that could have thrown up lots of false positives. And if things show up in the match complex types tab, these are all things that should be investigated, and a lot of time could be spent investigating things that actually aren't different, because it's just that the namespace prefixing wasn't consistent throughout the version. I mean, the thing to bear in mind with this application is that it's really something that highlights your attention to things. It's not saying, look, this is definitively wrong, i.e. these things are definitively duplicates. It's saying, you might want to look at this. There's something here. You might want to check it to see whether or not it's something that you want to pay attention to in your mapping. That's the ethos of the tool. Okay, so here it's just, you get a bird's eye view of how much is changing or not changing in between two versions. So on the left hand side, you have things that are dropped and things that are new. So of course, the more populated the left hand side is, the left half of the screen is, then the more volatility there is. To the extreme right, you have things that didn't change at all, so you have a less volatile upgrade. Same concept here. Look at this is actually comparing two schemas that are not sequential, i.e. we've ignored the schemas in between, the intermediate schemas, and gone straight from version 3.0 to version 4.3 of these two, right? Which is something that you can do when you generate the files, which I'll talk about a little bit later. You can specify that certain versions are to be excluded, so you can essentially compare anything you like. And what this is showing us is that between version 3.0 and 4.3, only two complex types, these two on the right here, escaped any change. So looks like we had, there was quite a bit of volatility between the two, in between those two versions, and that's something that someone might want to have a look at as to whether that is an accurate reflection of the real world, or does it highlight a problem in the modeling, that it's too inaccurate, which is why it's constantly changing. I'm going to switch gears now and show part of the actual app running. What you get is you get the selection box here, and it gives you the comparisons that's available to you. We'll pick the first one, 3.0 to 4.0, and you get the display, which you've seen on the previous screens, and you also have the ability here to specify search criteria. So I'm going to use that to illustrate sort of like a timeline. So there's a thing in this domain that we're looking at called a TMI, which is a traffic management initiative. And I'm just going to type in TMI in the search box. Right. Okay, so what this is, so between 3.0 and 4.0, we had 3 new TMI complex types introduced, and there was one existing one. The 4.0 NAS TMI type is obviously a superset of the 4.1, which is why there is no 4.1 button. Okay, so let's now just select a different pairing. So let's go from 4.0 to 4.1. So what this shows us is that in version 4.1, 3 of those complex types remained unchanged, and one of them stopped referencing a TMI entity. Let's look at the next pairing now, schemas. And okay, it looks like there was no change between 4.1 and 4.2, which is where everything is in the identical column. And then finally here, right, so it's all systems change in between 4.2 and 4.3. We've got we've got some complex types being dropped. We have some new complex types being introduced. And then we have some comparisons. So now I'm going to talk about another timeline use case where we track the inception and demise of a concept. So to do that, let's go to versions 3.0 and 4 again. I'm going to track what happens to destination over time. So as I type my search criteria, notice how the results change. That is the implementation of incremental search with XForms. So we have here, you see, introduced into version 4.0, we have a destination type and a NAS destination type. But let's now go forward and see what happens in version 4.1. So version 4.1, the NAS destination type has dropped, whereas the destination type remains intact. Going forward to version 4.2, now the destination type is dropped. Okay, and does anything happen in version 4.3? No, this is disappeared from the face of the earth. So obviously, when looking at version 4.2, one of the questions will be what's happened to the content model that was in destination type. We'll have a quick look at it here, and these are the things that you would be tracking. See, there's some clues here. You see arrival type in the annotations of one of the attribute, and then the last element. It looks like those things have been dispersed into arrival type and departure type. This is the same schema, but now we're looking at simple types. Pre-expanded a few things. So here we see that instead of the annotations here are showing that directional reference type has enumerations, and these are the enumerated values. This simple type here is showing some facets. So you see you've got a length facet and a pattern facet between version 3.0 and 4.0. What we're seeing is that Provenance center type changes type from string to character string. Oh, there is one more thing. If we look at the match between relative point type in version 3.0 and 4.0, let's expand this here briefly. One thing I've not mentioned here, the hyphen preceding a part of the content model is designating an extension. So what we're seeing here is that between 3.0 and 4.0, the extension changed from fixed point type to significant point type. So that's it for the app. Let's return to the presentation. So looking again at other approaches to this, Priscilla Walmsley presented on comparing and diffing XML schemas in 2015 at Balasage, and her experience was very different to what I experienced in developing this tool. So I want to talk a little bit about some of the reasons why that might be. So just talking about, in the approach, talks about write some code, run it, bang head against wall, reread note to self, current status of basic working code, much untested code, long list of future enhancements. Whereas at the bottom here, I'm talking about only having 190 lines of XLT split over 4 modules, 120 lines of XQuery split over 2, and 122 lines of CSS. I'm going to go into some of that later. Now, part of the reason for the differences is accounted for in the steps that she took versus what I took. So SchemaCom only entails steps 2, 5, and 7. Right? So we are only flattening, finding diffs, and then reporting, and that's it. So it's interesting to see why we're able to do that. And really, the main point is that SchemaCom is not a diff tool. It entails diffing, because to work out what you need to specify in a mapping, you need to know what the differences are, but it's not a diff tool. Therefore, there are lots of diffing banana skins that we're able to sidestep, right? So let's just go through these points here, or some of them. So it's designed to assist in the derivation of mappings for a vocabulary translation. It's only incidentally a diff tool, right? So what does that mean? Well, first of all, we don't have to worry about subsetting or backward compatibility. Well, to the extent that we may do a reverse translation, but that's not really aimed at backward compatibility. That's simply doing a translation in the other direction and going from a higher version to a earlier version. But we're not concerned with compatibility or subsetting as concepts. Okay. Only tested on XD 1.0 was actually common to both approaches. We don't have to worry about compositors, annotations, or documentation, because these things do not visibly impact the instance. If you change from a sequence to a choice, that doesn't affect your mappings. Also, we don't have to worry about changes to groups or attribute groups, because we're inlining them, and so we'll handle any changes in the content models that reference them. Right? we're not concerned with changes to element sequencing because because first of all, it doesn't require us to change the mapping, and in any event, we can pull data from the instances in the sequence which has been determined by the target schema. Finally, we don't handle anonymous types. If you want to find out whether something has been dropped or added, you're looking for the appearance of the name of the entity in one schema and not the other. If the entity has no name, then it's not possible to monitor that. So we don't make any attempt to do so. Let's take a look at the code. So there's a step to generate all the schemas in the vocabulary. This is the pseudocode description of it, and in white here you have a schematic of the output format. So you're going to get an all schemas parent with a schemas element for each version of the schema. So this here is all schemas XSL, and we note here there's a parameter to exclude versions, so you can tell it when it's assembling the schemas XML file, you can tell it which versions to exclude if you want to. There's not a jiggery pokery, but basically it's recursing over the collection, or traversing over the collection, I should say, and it's using FN transform to apply a style sheet, which in this case is schemas XSL, which I'm showing you here now. So schemas XSL, which is called against each of the schemas that are traversed, inlines attribute groups and references and gets rid of any annotations. That's basically all it does. Next, we'll look at schema deltas.xq, which is the X query to generate the comparisons. So this is the design for it. So it takes the all schemas output, which is here, and pairs up each schema, and then to that pairing it applies complex deltas XSL or simple deltas XSL, depending on whether it's running for complex or simple types. And I'll show you the code. So here's schema deltas .xq, the X query. So we've got a sliding window which operates over the schemas file, so it pairs them up. And you notice here we create a document node where we put a pairing wrapper around each pairing. This is the pairing here. There's a pairing wrapper around it, and the pairing wrapper says what versions are being compared, what pair of versions are being compared, and we apply via FN transform. We apply a style sheet which will either be complex deltas or simple deltas.xsl. And the content of each schema's element that you see here will be the result of the comparisons. So I'm going to show you the code that generates the delta XMLs, mostly to show you how small it is. On the left-hand side is the simple deltas XML, XSL, and on the right-hand side is the complex delta style sheet. The key is this template rule here, in the case of simple types, which counts the number of times that simple type appears in a schema. And if it only appears once, then it's unmatched. And if it's unmatched and appears in the source, it's been dropped. If unmatched appears in the target, it's new. The other case is where the simple type appears more than once, and that's here. And then we look here to see which bits differ. And if this results in the empty set, then you've got a match with no differing bits, which means that it's identical. And if there's anything that does come back from here, then those are the differences. Last bit of code is the X query that generates the XForm. So the logic is the delta files that we just created become the XForm model, and that's bound to UI controls and rendered as XHTML. That X query is here, and it's all of that's it. It's all of 70 lines. So that's all the code. So I'm now going to show how easy it is to set up SchemaCom to run over a different schema configuration. So if you look at the drop down here, you notice that I've only got one set of comparisons because I've excluded versions 4.0, 4.1, and 4.2, i.e. all intermediate versions between 3.0 and 4.3. So how do we do this? You run the job shell script here. You run this shell script at the bottom here, and the parameters are this here is a system, so it's fixum, and then you give it a comma separated list of the versions you want to exclude. That sets the exclude versions parameter on the X query that I referred to earlier, and then that's how you get this. You get the configuration I just showed you. So reiterating what made this an approachable problem, we were able to ignore changes that weren't going to be visible in the XML instances. So this made it easier for us to keep track of differences. Now, in actual fact, we do track differences in optionality and cardinality between schema versions, but they're not exposed on the GUI, and that was just something that is held in the underlying files. Secondly, this is just a heuristic guess as to what the mapping should be. That is the goal of this system, so we don't have to have unerring accuracy in our results. Finally, a post-mortem on the whole experience. Whatever's been achieved here is the result of naively trying to solve a similar but different problem. So that I think it accounts also for the different experiences I had than other researchers in this area. Future work, the UI degrades with the large XForm model. So there's some things you could do there to improve performance. Adapting the interface to allow mappings to be specified and not just discovered. But that will be challenging because there doesn't seem to be much room on the UI for additional interactions. And then encoding a schema as a function of its similarities and differences to another schema. So I'm not quite sure what one would do with that, but that is a possibility. Finally, I'd like to thank Hans-Jürgen Renau for reviewing the paper, the application, and providing valuable and extensive feedback. One last note, the code is not publicly available. That's something that I'd have to speak with my employer about, but I welcome inquiries. Thank you very much.